start with the presentation. So let's start with the presentation of Shutong He with the work Cognition, Energy Literacy, and the Class Valuation Effect for Energy Labels. When you want, go ahead.
Yeah, thanks for the introduction. Yeah, I'm not mute. All right. Then in the following 20 minutes, I will introduce our work on energy labels and heuristic decision making. And we specifically look into the role of cognitive style and energy literacy. And my name is Shutong He, and this work is co-authored with my two PhD supervisors, Blasch and Pieter from Beukering, as well as my master supervisor, Zheng Wang from Nankai University. Yeah. Let's first take a look at the labels that are currently used in the world. These labels that we frequently see on our household appliances, such as refrigerators and air conditioners, we call them comparative labels, which means that this kind of label allows us to compare the energy performance between different products. And if we want, we can compare technical specifications such as the volumes and noise levels of the different appliances. And the four labels on the left, this kind of label allows us to compare by categories, either on an alphabetical or numerical scale or on star ratings. And the two labels on the right side, we call them continuous scale label because this kind of label allows us to compare on this continuous scale. And these two types of labels, the categorical scale label and the continuous scale label, are the ones that we will focus in this study. As indicated by some early study, the categorical scale label are preferred by many consumers because the classes themselves are very intuitive. However, this could come at the cost of the preciseness. As recently indicated by Andor and his colleagues, this kind of label can introduce heuristic decision-making in the sense that consumers may value the efficiency class per se while ignoring more precise information, the difference in energy use. This kind of heuristics is known as class valuation effect. Just to take the two labels on the right side as example, these two labels represent for two refrigerators. The difference in annual electricity consumption is only 1 kilowatt hours. However, the two refrigerators fall into two efficiency classes at the threshold of class A double plus. So when making decisions based on this categorical scale label, consumers may just make cost inefficient decisions because of the abstract efficiency classes. However, on the other hand, if we consider a continuous scale label, this kind of label allows us to make a direct comparison on this continuous scale. Even when the efficiency levels are close to each other, consumers should notice this subtle difference. Therefore, this study tries to understand the effectiveness of different visualizations of energy efficiency information on the labels, either on a continuous scale label or on a categorical scale label. Further, we consider energy labeling is a widespread policy instrument across the world, and also the effectiveness of labels can depend on how individuals perceive and process the information. And this information processing procedure can associate with an individual's cognitive style, personal values, knowledge, habits, and so on. These factors can also systematically be different across countries. Therefore, we decide to conduct a cross-country study to understand the effectiveness of these two kinds of labels. And taken together, we aim to investigate two research questions. First, how effective continuous scale versus categorical scale labels are in correcting the heuristics leading to the class valuation effect. And second, how the perception and processing of information on energy labels relates to an individual's cognitive style and energy literacy. To explore these two questions, we designed such a decision task embedded in a survey questionnaire. And participants were asked to imagine that they are purchasing a new refrigerator. What they need to do is to choose the refrigerator that between these two similar models that can minimize their expenditure during the lifetime, which means that we ask the participants to make a cost-efficient decision. And participants were randomly assigned to one of these two label treatments, either make their decision based on a continuous scale label or make their decision based on this categorical scale label. Apart from the between subjects treatments, each subject was asked to make 3 decisions under different situations, which is our 3 within subject situations in random order. And we are especially interested in this situation B, where the two appliances belong to 2 different efficiency classes. However, their annual electricity consumption and their efficiency level are quite close to each other. We would like to explore whether a continuous scale label can correct such decision heuristics in this specific situation. As mentioned, the decision task was embedded in the survey questionnaire. And in the survey questionnaire, we also elicited some individual level characteristics, including their socio-demographic information, the energy literacy level, including 3 aspects: the energy-related knowledge, energy-saving attitudes, and energy-saving behaviors. Also, we measure holistic cognitive tendency in this questionnaire, which is related to how an individual process the visualization differently. And finally, we control for reasons of making the decision. And in this cross-country study, we collected data in the Netherlands and China. And in the end, we have almost 1,000 valid responses for the Dutch sample and 1,041 valid responses for the Chinese sample. And the median duration of completion was about 17 minutes in both samples. Okay, to answer our research question, we conducted a series of random effects probability models. And I will present the variables of interest specifically to certain research questions separately. One more thing to explain is that, as you can see here in the table, we present the results for the Chinese sample and for the Dutch sample separately. This is because we observe distinct patterns in individual characteristics, their decision-making patterns, and the magnitude and sign in the coefficients of explanatory variables differently in these 2 samples. Therefore, we decided to regress separately for them and compare the results afterwards. This result is for the main effect of a continuous scale label. And we see from these results that on average, indicating the energy efficiency with a continuous scale label may increase the likelihood of correct identification of the more cost-efficient appliances by around 3 percentage points among these 2 samples. However, both p-values are over the at least 0.10 threshold. Therefore, we cannot say something about the main effect of the continuous scale label. Further, as we are specifically interested in whether a continuous scale label is more efficient in a specific situation, therefore we introduce an interaction between the label treatment and our situation B, in which a categorical label can easily introduce heuristic decision-making. However, we did not observe any significant effect in the Chinese sample. But for the Dutch sample, we see that in this situation B, having the energy efficiency information on a continuous scale label increased the likelihood of correct identification by 11.6 percentage points. This is a significant result, which means that at least for the Dutch sample, in this situation, a continuous scale label can correct for the decision-making heuristics. Further, we are interested in whether for specific kinds of respondents, a continuous scale label is more effective. And we consider the holistic cognitive style can influence how people process the continuous scale label information. I don't think that I have time to go through these details of this concept, but basically the holistic and analytic cognitive styles are used to understand how people in different cultures view the relationships between different things, what they pay attention to when viewing a picture, and what is their standard when categorizing different items. In short, our hypothesis is that people with relatively high holistic cognitive tendency measured on this scale will process the information on a continuous scale label more efficiently. Because people have holistic cognitive style, they are found to make less use of categories for the purpose of inductive inferences. Therefore, they may use more like the continuous scale label. The results show that in the Chinese sample, we do not observe any significant interaction effect again. However, for the Dutch sample, we see that from individuals with a holistic cognitive tendency score above 0.65, the continuous scale label is more effective in decision-making compared to the categorical scale label. And as the score increases from 0.65 to 1, the continuous scale label can increase the probability of correct identification from 3 percentage points to 9 percentage points. As we also consider from the theory that the holistic cognitive tendency can systematically differ between countries, and based on theory, the Chinese respondents are expected to have higher holistic cognitive tendency, while the Dutch respondents may have lower holistic cognitive tendency. Therefore, we further look into whether the effectiveness of this interaction is different from between these two samples. First, we conducted a t-test to observe whether the holistic cognitive tendency itself differ between these two countries. And indeed, we see that the Chinese respondents show a higher score in the sense of this cognitive tendency compared to Dutch respondents. However, when we conducted a CEST method to compare the results of the continuous scale label, we do not see a significant different results for the effectiveness of the continuous scale label. Therefore, we can not say something about that, that if the Chinese respondents can use better of the continuous scale label. And then we come to the last part of our hypothesis is on the energy literacy. We're interested in these concepts because we think the energy literacy idea includes the knowledge, attitudes, and behavior scales, and this can be systematically different across countries as well. From the results, we see that being familiar with daily life energy-related knowledge, the energy-related policies such as subsidies for electric vehicles and the household tariffs, this kind of policies, as well as the use of daily life appliances such as a desktop, can increase their probability of correct identification by 5 percentage points to 12 percentage points in these two samples. And further, especially in the Chinese sample, having the knowledge on LED light bulbs can also increase their correct identification likelihood by 5 percentage points. The other two aspects of energy literacy, the attitudes and behaviors, we only observe that the attitudes in the Chinese sample may decrease the likelihood of correct identification. This could because if people have higher energy saving attitudes, they may value the energy efficiency to a larger extent. Therefore, they do not care, or they tend to make less cost-efficient decisions. So these are our results, respond to our 3 hypotheses. And based on the results, we further put forward 2 parts of discussion. And the first part is that we observe insignificant interaction effects, specifically within the Chinese sample. And we identify 3 possible reasons for these insignificant interaction effects. One could be that we only measure the holistic cognitive style on this 10-item scale. However, there could be factors beyond our measurement, which can influence people's processing of the visualization. Further, people may bring their life experiences to the experiment. And in our experiment, the Chinese respondents may overall be used to the continuous representation in percentage because that we have this 100 score in the exams. However, the Dutch respondents may be more familiar with the grades. Therefore, the continuous scale label can naturally be more effective in the Chinese sample, and we do not see the significant interaction effects in the Chinese sample. Another possible explanation is that the annual electricity consumption information can draw the attention of Chinese participants in particular, because the current China energy label only has the information on daily electricity consumption, while the EU energy label has the information on annual electricity consumption. Therefore, this difference may let the Chinese participants pay particular attention to the annual electricity consumption, therefore make their decision also based on this piece of information. Another part of the discussion is that we notice the differences in explanatory power of all 3 models between China and the Netherlands. Taking the model 3 as an example, in which we include all the explanatory and control variables in this model, the McFadden's to the R² with the Dutch sample is 0.25. However, it is only 0.06 within the Chinese sample. This phenomenon may imply that there could be other explanatory factors beyond our model that are important for the decision-making, especially for the Chinese respondents. And this kind of phenomenon, the same model, but with multiple samples, the explanatory power can be different. This kind of phenomenon was also demonstrated in other studies with multiple samples, such as the 2 studies I listed here. And I would like also to know your opinion about the possible reasons of the difference in the explanatory power, and also whether this could be an issue or problem that we should take specific cautious about. Okay, and to conclude, our findings overall do not allow a clear conclusion on the effect of continuous scale label in increasing the probability of correct identification of the cost-efficient appliances. However, we find that the continuous scale label is especially useful in correcting for the class valuation effect for the Dutch sample. It can increase the likelihood of the correct identification by 11 percentage points compared to the categorical label. Further, the effectiveness of continuous scale label significantly surpasses the categorical label for people with a pronounced holistic cognitive style, also only in the Dutch sample. The other 2 implications from this study are that other than gender-related, energy-related knowledge, such as knowledge on renewable energies and on the generation methods of electricity, the awareness of daily life-related knowledge about electricity policy and the energy use of household devices indeed translate into more conscious investment decisions. And the last piece of implication is that the nurturing energy-saving attitudes, although may not lead to cost-efficient decisions, but can indeed increase consumers' valuation of efficient class. Okay, so that is the main contents of this study, and I would like to know your comments and questions. Thank you.
Thank you very much, Shutong. If you have any question, you can write on the chat that is down. There is a button that puts chat. I'm going to make you some questions. The first of all, you say that you control from gender and age. Did you control also home composition, education, and income of the participants?
Yes, we controlled age, gender, income, education, yeah, those socio-demographic information.
And did you see any differences on the understanding of the continuous level depending on the education, for example, or in the income? Or did you see no difference?
Yeah, I should check that. Let me switch to.
The minutes are gone.
I think the results was not prominent, therefore we do not explain it specifically. Let me see. Yeah, we actually observed that for the medium income level, it decreases the correct identification of the cost-efficient appliances. Yeah, this is the coefficient, and in terms of the, this is for the Chinese sample, and in terms of the average partial effects. Yeah, here.
Okay. Has anyone have any kind of question? I will give some minutes to write. No one has a question? Cannot believe it. So we can go on to the next speaker if you want, and then at the end we can make a discussion of the three of presenters. I mean the three works. Now Xingchi Shen, I'm not sure if I have pronounced it correctly, I'm sorry about that, will present the work, the impacts of special environmental events on electricity saving behaviors, evidence from a high frequency smart meter data of residential and non-residential consumer. When you want.
Okay, thank you. Let me share my screen. Can you see my slides? Okay, great. So hello everyone. Thank you so much for coming. Today I'm going to talk about our recent working paper. It is about the impacts of special environmental events on the electricity saving behaviors, evidence from Shanghai, a city in China. And this paper is caused with Professor Lucy Chiu, and she is an associate professor in the University of Maryland, and the two other co-authors who worked in the utility companies in China. So this is the outline of my presentation. First of all, let me talk about the motivation or the introduction to this paper. So as we all know, the traditional energy policy instruments are focused on changing the relative prices to improve the energy efficiency or encourage the energy conservation behaviors to internalize their externalities. Usually we have some very common approaches such as the carbon tax, pollution tax, energy efficiency subsidies, and so on. So these are common approaches, and also they have been implemented by so many governments, but they do have some shortcomings, such as the expensive implementation costs. And also this some market-based approaches can have some inequitable outcomes between the rich and the poor communities. So more and more people, more and more scholars and policymakers are increasingly interested in using another approach, nudges, social nudge, which is the focus of this paper. So we are interested including how to utilize the information provision or social compressions or persuasion to change people's behavior or change people's demand to the energy or other behaviors. And typically, this approach have one advantage, which is inexpensive. Typically, it is inexpensive compared to the price-based approaches. So there are some famous examples. For example, the O-power letter. It used the social compression messages to help reduce the energy and water consumption in the short run. And more papers and studies following the line of the social nudge. And they also explored other questions such as whether the effects can persist. And they also compare the nudge policy with the economic incentives. However, there's one kind of social nudge activities that have not been studied by the scholars. Today we are talking about, that's the focus of this paper, the special environmental events. So the special environmental events can be regarded as a specific form of social nudges. For example, the policy document of 2017, working arrangements for the energy conservation, emission reduction, and tackling climate change, introduced by the Shanghai Development and Reform Commission. It required that the government institutions at various levels to organize publicity campaigns on the day of some big environmental events in order to improve citizens' environmental protection and energy conservation awareness. And in our paper, we focused on 3 such environmental events that have been very popular around the world and also in China. The first event is Earth Hour. It is a worldwide movement organized by the Worldwide Fund for Nature, which organized immutable symbolic activity that switch off the lights for 1 hour in order to encourage people to protect the environmental and also save energy. And the second, we focused on the World Environmental Day, which is just, I think 3 days ago. It happened yearly on the 5th of June every year for raising up awareness on the environmental issues and also improve the energy saving awareness. It is also very popular around the world. And the last event is National Energy Saving Publicity Week, which is just organized in China. It was established by the State Council since 1990. It was held annually, and in 2017, the Shanghai government carried out a total of 440 activities with the theme of energy conservation and emission reduction during this week, from June 11 to 17. So that's the 3 events that our paper is focused on. And let's talk about our contributions. So first of all, these events, our paper provides the first empirical evidence of the impacts of these events on consumers' electricity consumption behaviors. I think there's no, there are some papers investigated the impacts of the Earth Hour on electricity consumption, but there's no, but their estimation are very, I think it's just based on the simulation or just the back of envelope analysis. And our paper is the first paper which provides a comprehensive and I think a robust estimation about these effects. And the second contribution is that these effects have been very popular and organized by so many countries. So many governments have paid so many efforts on these events. So it is critical to understand whether these efforts are worthy in terms of changing consumer electricity consumption behaviors. And the third contribution of this study is that the private studies only focused on the residential consumers, and this paper also examined the commercial consumers. So we focused on both the residential and the commercial consumers. So basically, in this paper or in this presentation, I'm going to talking about 2 research objectives. The first is to estimate the average effect of the special environmental events on electricity consumption behaviors in Shanghai. And secondly, we are focusing on analyzing the mechanisms behind the effect. I want to discuss why the consumers have such behaviors. And we have two kinds of main data. The first data is the social media data, and the second data is the smart meter data. So to explore the mechanisms and also the activities that happen during these events, we utilize the social media data. Because a substantial amount of information and messages are provided about the energy conservation around these events. And these messages can be spread by several channels, such as the government agencies, and non-government organizations, and the companies, individuals, and the social media can be one of the important channels. So we just capture all the social media tweets during the time of these events, and these users are also located in Shanghai. So so this is a figure showing the evolution of the people of the number of the tweets about these events. So this line shows the number of the tweets with the words of the event's names and also with the words of energy saving. You can find that the number of the tweets with the words of the event's names peaked significantly on the day of these events. And also the number of the tweets with the words of energy saving also peaked during these events. And more importantly, you can find that the Earth Hour aroused much more public attention compared to the other two events. This might be because the symbolic activity can arouse more attention compared to another two traditional campaigns. And secondly, we have another major data set, which is the smart meter data. We obtained this smart meter data from the State Grid Corporation, which is the largest utility in China. And we have both commercial and residential electricity use data. The commercial electricity data is at 15 minutes level, and it covers 680 consumers randomly drawn from all the smart metered commercial users in Pudong district of Shanghai over 1 year period from 2017 to 2018. And also we have a residential electricity use data, but it is only at a daily level, and it covers about 1,700 consumers in Pudong district of Shanghai at the same time period. By the way, we also have the hourly weather data, which are the control variables in our model. And then let's talk about our methods. So because every individuals and every regions in China, they just stepped into the events at the same time, so that there's no cross-sectional difference in the treatment about the environmental events to enable us to conduct a DID analysis, difference in differences analysis. So in other words, we do not have a control group. So in order to address the endogeneity issues, we adopted this two-step local linear method to control for the confounding factors, which is similar to the method of this paper written by the Holzman and Rapson in 2018. So we have two stages. First stage, we use the global data set, which just across the whole 1 year time period. And then we just put everything into the model. The outcome variable is the power use, it's the electricity use for individual household at the 15 minutes level or at daily level. And we have all the variables we have, such as the temperature, pressure, wind speed, and other weather variables. And also we control for so many kinds of time fixed effects, such as the holiday fixed effects, months of year fixed effects, day of month fixed effects, day of week fixed effects, and hour of day fixed effects. So that's our first stage. And during our second stage, we save the residues from the first stage, and then we focused on a very short time window and only using the residues from the first stage to conduct OLS model to compare the electricity consumption between after and before the events. So the reason why we focus on the short time window is to help us control for the confounding factors. Because if we have a longer time window, we may include more confounding factors. So that's why we adopted two-stage methods. And in the second stage, it is a simple OLS model. The outcome variable is the residues from the first stage, and we have the D. The D is the treatment variable, which only takes value 1 after the event. And we bootstrap and crossed our standard errors at the individual levels. So that's our major method, the two-stage local linear method. And following is our results. So that's the overall results. All the results of our baseline estimations include 3 different events and also both the residential and the commercial users. And the black points are the point estimators, and the yellow and the arrow bar, the green arrow bar are the 95% confidence intervals. So let me deepen into the results. So first, let's look at the world environmental day and the energy saving week. And for the commercial users, we can find that both the commercial users had a significant energy saving behaviors on the day and on the second day of after the World Environmental Day, but the energy saving effect declined rapidly over the next 2 days. But within the events, you can find that there's about around 70% of a reduction of the electricity use. And for the energy saving week, the commercial users also had a significant energy saving behaviors within the whole week. But after the week, the effect decayed rapidly to be insignificant when the week ended. And within the week, the reduction is about 8%. And unfortunately, we found that there's no significant impacts on the electricity use for the residential users during both World Environmental Day and the National Energy Saving Publicity Week. And another result for the Earth Hour, we found that both for the residential and the commercial users, we do not find a significant electricity saving effects during the Earth Hour, during the day of the Earth Hour. And also, which is more interesting, we found that there's a rebounding effect on commercial and residential consumers after the Earth Hour. So this is a dilemma. We found that because Earth Hour is a special event aimed at encouraging people to save energy, which, however, it costs and also it costs more public attention compared to another 2 events. However, the Earth Hour did not lead to any average energy saving effects. So why are the results? So we are interested in the mechanism behind these findings. So we have some preliminary findings from the mechanism analysis currently. So I would like to share with you. Oh, by the way, we have another robust checks using the machine learning approach to predict the counterfactor of the electricity consumption. Because of the time limitation, I think I need to skip it. But the major results are consistent with our previous baseline estimations. So let's just move to the mechanism analysis section. So as I just mentioned, we also use the social media data. So we use the social media data to explore the mechanism behind these effects. We review, besides the social media data, we also use the policy documents data. We also reviewed all the related policy documents in 2017. And then we also scrubbed all the tweets from the Xinlang Weibo, which is the largest social media in China. And we used both the data sets to explore the mechanism. So by concluding all the activities we found from the policy documents and also the social media and texts, we conclude all the activities in this figure. All the activities happened or organized by different organizations. You can find all the activities in this figure. For example, in the Earth hour, the typical measures is turning off the lights for 1 hour. For example, some hotel or some landmark buildings will turn off their out lights for 1 hour at night. And also some activities like the night running, cycling, or art performance. However, when we look at the mechanism, look at the measures or activities happened during the World Environment Day and also the National Energy Saving Week, we found very different kinds of activities, such as the environmental knowledge competition, technology innovation competition, expert speech, workshop, and also the professional skill training, and so on. So to conclude, we found that most activities during the World Environment Day and the National Energy Saving Week are directly related to the knowledge and the skills of environmental protection and energy saving. However, we found that most activities during the Earth hour are symbolic behaviors like turning off lights. Yueming thought that turning off the lights for 1 hour may have the impact on the electricity consumption because you just turn off the lights. But we argue that because only some of the buildings, some landmark buildings, turn off the lights, and also it only turn off the lights for 1 hour. So this impacts on the electricity grid can be very minimal. So we call it minimal activity. We call it symbolic behaviors. So that's our mechanism analysis. I think this is not a causal inference. I mean, in the mechanism analysis, we are not doing a causal inference. We just collect all the information we can find and try to find some correlative clues or try to find some correlative evidence to help us understand why there's some different findings between these events, provided some implication for the future studies. So let's talk about the conclusions. So based on our baseline estimation, we found that the commercial users save the electricity consumption statistically significantly during the events of the World Environment Day and the National Energy Saving Publicity Week. It is around 70% and 80% reduction compared to the average consumption. And so, however, we should pay special attention to the event of the Earth hour because we found that we do not find any energy saving effects during or after the Earth hour events. So we should pay special attention to the events of the Earth hour. Also, the immutable symbolic activity of the Earth hour aroused people's much more greater attention. It had a very limited power to lead to actual energy saving behaviors. So policymakers should think about adopting more activities that are directly related to the knowledge and the skills of the environmental protection and energy saving, like during the Earth hour events, to help improve the effectiveness of these events. And moreover, we should pay special attention to the residential users because we do not find any significant energy saving effects for the residential users. And also we do not and also we should pay more attention to the off-peak energy saving potential. Because of the time limitation, I did not talk about the hourly heterogeneity of our findings. So you may find it is so this implication, maybe we can talk it later because of the time limitation, I cannot discuss it today. And the last, the policymakers and the environmental communities should continue to support the special environmental events. Also, the short-run energy saving effects caused by the events decrease rapidly. we should acknowledge that the short-run behavior change reflects a change in people's awareness. Only the change in awareness can determine people's long-run behavior. So that's all. Thank you for your attention.
Congratulations for your presentation. Really interesting. I have two questions related to the rebound effect that you mentioned. You mentioned a rebound effect for the Earth Hour, but did you find a rebound effect also for the Energy Saving Publicity Week or not?
Let me check the, so for the commercial users, we do not find any short-run rebounding effect. You can check this graph. So you can see my slides, right?
Yeah.
But we do find a short rebounding effect for the residential users at these 2 days. So we are also very curious about why there's rebounding effects for the residential users after the energy saving week.
And did you have the data only for this year, or are you going to measure on different years to ensure that this rebound effect remains yearly?
Currently, we only have 1 year from it's on 2017, but maybe we could ask our co-authors for more data. Yeah,
it could be interesting to see if this kind of policies like the National Energy Saving Publicity Week or the World Environmental Day or this kind of policies have a rebound effect on energy consumption.
Yes, that's a great point. Thank you.
I think that Shutong has a question. I think so.
Yeah. Let me read the question.
Thanks. So. Yeah, I was just applauding. Sorry. Yeah, but I did have a question about the rebound effect. Yeah, you mentioned that you controlled for the weather condition, and did you control for whether the day is in weekend or during the weekdays? I was just thinking maybe during the weekend, the residential energy consumption behavior can be different.
Yeah, I think we have the day of week fixed effects from the Monday to Sunday here. The day of week fixed effects.
Yeah, I missed the information, sorry. And another, not question, but rather a remark is that I think your explore of the mechanism is consistent with what they found in the All Power program. I think they provide the tailored tips for saving electricity to the households. And this piece of electricity saving knowledge or tips can especially help them to reduce their electricity consumption. However, in our study, we have another study to give participants and the information on energy labels to ask for their preference for refrigerators. In that study, we did not find that the knowledge, energy-related knowledge, can lead to different investment decisions, or say the energy-related knowledge did not increase people's preference for more energy-efficient appliances when making investment decisions. So I think there could be difference between making investment decision and using their electricity in daily life.
Yeah, I think that's for I think you make a very good point, because I think the investment decision is different from the consumption behavior, because the energy efficient investment could have a very high upfront cost. Like you purchase a refrigerator or the air conditioner, it could be expensive.
Indeed. And I think you have another question from the chat.
Yeah, from James.
James Carroll asks, have you any survey evidence on the share of household firms who are aware of these nudges?
Yeah.
And do you know if each received equal amounts of marketing expenditure? 2 questions.
Yeah, 2 good questions. To be honest, my answer is no. I do not know. I do not have evidence, direct evidence, whether they be aware of this, of the nudges in our sample. So my only evidence that I assume they know, and also from the social media data, I assume that a large part of the consumers know the events. But I do not know whether my sample respondents know these nudges. However, which is one shortcoming of this our study, because we do not know the location or any identification information about our samples, so we cannot do the survey to our respondents. But I think the survey still could be a very important approach to further explore the mechanism. Yeah. Thank you for your question. Yeah.
Are there more questions, sir, in the chat? No. Okay. Pues I go on.
Thank you.
It's my turn now. I think that now you can see my screen. Just confirm. Yeah. Okay. Thank you. Now I'm going to present the third chapter of my PhD dissertation, which is entitled "Effectiveness of Monetary Information to Promote the Purchase of Energy Efficient Appliances: Evidence from a Field Experiment on a Big Retailer in Spain." This is part of CONCERT project, which James is my colleague from the project. In this project, this project aims to understand the consumer decision making and the effectiveness of energy efficiency labels. This project involves different parts. We start with a literature review that has been recently published by myself. Then we have other qualitative research, like focus groups and in-depth interviews and so on. And then quantitative research, such as surveys, field experiments, and so on. The outline of the presentation is going to be this one. First, I will start with a brief introduction about energy efficiency labels and so on. Then I will explain the motivation and the objectives of this study. Then the design of this field experiment, the methodology used, and the results and conclusions and policy recommendations. Household energy consumption, as you know, is one of the main responsibles of energy consumption in Europe. It is responsible of around 26%. So in this point, it's really important to encourage and to promote the purchase of highly efficient appliances and products in general. Sometimes consumers do not take advantage of this kind of technologies, and this is the so-called energy efficiency gap. There are several failures that could explain this energy efficiency gap: informational failures, market failures, and behavioral failures. To cope with these failures, we have a lot of policies. One of them, and the most relevant one or the most famous one, are energy efficiency labels. This kind of policies usually provide information on energy consumption of the product. In Europe, labels must be displayed by law in the most energy-using durable goods here in Europe. This presentation will focus mainly on energy efficiency labels for appliances. And perhaps you know that there was a rescale in the European energy efficiency labels this March. As you can see, in the left part is the old label. I'm gonna mark it as a point, this one. The scale was from A++ till D, and now the scale of the new energy efficiency label is from A to G. Another change is that in the case of washing machines and dishwashers, in the old energy efficiency labels, the energy consumption appeared per year. It appears here, the energy consumption per year, and now it appears for 100 uses. In the case of fridges, the energy consumption, it remains the same. Regarding the objectives and the motivation of this study, we want to promote the purchase of highly efficient appliances at household sector in Spain. For that, we would like to test the effectiveness of presenting energy consumption information in euros, in lifetime energy cost. We did this with a field experiment. We believe that a field experiment would be a good opportunity to test with real sales and real situation if this kind of policy could be effective. Regarding the design of the field experiment, we ran the experiment in a big retailer in Spain, El Corte Inglés. For appliances, we choose to take 4 appliances: washing machines, fridges, dishwashers, and tumble dryers. The experiment has 2 groups: control group, that is this one, that behave as usual during the whole experiment, and then treatment one, in which sales staff were responsible of providing monetary information. And then a second treatment that was a combined treatment. First, there was the sales staff that was informing the consumers about the monetary information of that product, but also in each product, in each appliance, it appears a complementary label. The duration of this experiment was around 4 months. It started on August, mid-August, till December. And it's important to remark that a rebate program called Renove was enforced before starting the experiment. The Renove rebate program, perhaps you know it, but it provides subsidies for the replacement of household appliances for new and more energy efficient ones. This is run usually by regional governments, and we believe that this could be an interesting opportunity to test if the rebate programs have a long run effect. This is what we call memory effect. Regarding the estimation of the lifetime energy cost, for this estimation, we simply calculate by a multiplication, by multiplying the energy consumption of the product times the energy price of that year and times the lifetime. We consider a 10 years lifetime. This is the label that we used with the logo of El Corte Inglés and the logo of the research center. And regarding the methodology, we ran a multinomial logistic regression. Here, TRAT 1 will take value 1 if the sale happened during the first treatment. TRAT 2 take value 1 if the sale happened during the second treatment, and then we have the attributes of the product. Depending on the appliance, these attributes will change. In the case, for example, of washing machines, we have water consumption, capacity, and this kind of attributes. Then we have the variable of income. First, we try to obtain the income of the consumer. But El Corte Inglés was kind of reluctant to ask for this kind of information, and we finally take, thanks to the zip code of the shop, the average per capita income of the zone where the product was sold. So it's not going to be the income of the purchaser of the consumer, but it's going to be the income of the zone of the area where the product was sold. Then the catalog price of the appliance, and then a dummy variable Renove that is going to control if in that shop was a Renove or it wasn't. Okay. Regarding the results of the experiment, they are quite surprising for us, at least, because we saw that providing monetary information, both in treatment 1 and in treatment 2, was not effective for A++ washing machines, fridges, and dishwashers. Indeed, they decrease the probability of selling this kind of products. Then we could also see that in the case of tumble dryers, it increases the probability of selling this kind of product. Sorry. A potential explanation is that something out of our control, like for example, the sales staff, didn't work during the experiment. Perhaps sales staff did not encourage or nudge strongly this kind of sales, so we are not able to answer to these effects. Regarding the income and price effect, we could see that in the case of the income, in those zones, in those areas where the income is higher, I'm sorry, where the income is higher, is gonna be lower the probability of selling H++ highly efficient fridges. Regarding the price, in the case of washing machines, we could see an interesting effect, and is that as higher is the price, the lower the probability of selling this kind of product. A potential explanation to this effect is that the difference on the catalog prices, the difference between A++ and A++ washing machines is not gonna be worthy to compensate the difference on the lifetime energy cost difference there. Then for fridges, dishwashers, and tumble dryers, we could see that as higher is the price, higher the probability of buying a highly efficient product. That is quite sensible. In the case of the Renove, the rebate program, these are quite surprising results because we didn't expect to have any kind of effect here, but we saw that in the case of washing machines, fridges, and dishwashers, if the sale happened in a place where a Renove was run, we see that increases the probability of selling highly efficient products. This effect was not found for tumble dryers, but a potential explanation for this could be that tumble dryers were not in this rebate program, in this Renove rebate program. We didn't find such evidence on the literature, as we have been looking for different effects and different impacts of the rebate programs, and we have seen a lot of literature analyzing the impact and the effectiveness of rebate programs during the program itself, during that period. But we didn't find any kind of article analyzing the impact or the long-run effect of that rebate program once it is over. That is what we have called memory effect. So here one question arises. Does the Renove program have the same impact with the cells under control in the control group, those ones with no intervention? So what we have done is we propose a probit model only with the cells under control, those ones that they didn't do anything during the experiment, where our dependent variable is gonna be a dummy variable that is gonna take value 1 if the product is highly efficient, that is A++, and 0 otherwise. This analysis, also I remark that is done always with this probit model is run with control cells, those ones with no intervention. This probit model that I show you here is the one for washing machines. It's just an example where we include capacity, the type of embedding of the washing machine, and the water consumption, then the income and the Renove, and the price, of course. And once more, surprising results. Here we see that both for washing machines, fridges, and dishwashers, having a Renove program before starting the experiment increases the probability of selling during the experiment highly efficient appliances. This is what we called a memory effect. And there are several potential explanations for this effect. One, and the first one, it could happen that El Corte Inglés buy a lot of products. Once they know that a Renove program is coming, they could buy a lot of products, a lot of highly efficient appliances, just to have a stock in their shops. And then once the program is ended and they haven't sold everything that is in the stock, they have to get out of that stock and they start selling a lot of highly efficient products. Another explanation could be that consumers go to the shop still believing that there is a Renove program running. Nevertheless, we believe that further research is needed in this point, because we believe that could be interesting to analyze if this kind of effect, or this memory effect, is only applicable for washing machines, or is it is also applicable for other kinds of products such as vehicles or buildings or wherever. Also, we believe that further research is needed just to ensure that if this effect remain only for a few months, or it's gonna be for a long run effect. If it lasts for more. Then I would like to remark some caveats of this study, because we acknowledge that we have some. One of them is that we have no observation of the post-treatment period. We don't have any idea, any clue about the post-treatment effect. If the sales staff remain providing that information and so on. We are also unable to control information. We are also unable to control the information that the consumers receive. Also, we are unable to know the real socioeconomic variables of the consumers, because we did try to convince El Corte Inglés, but they were reluctant to ask for that kind of information, like home composition or income or age and this kind of variables. Then we have also here, it's important also to remark that we are not, there could happen that there are some consumers that went to the shop to ask for information during the treatment 1, but finally bought the product in treatment 2. So what we really see is that the purchase was done in treatment 2, so we included that in treatment 2. So that's a caveat of our study. And now conclusions and policy recommendations. It is true that the decision-making process for each appliance differ a lot, and also a lot of characteristics can affect this decision. Regarding the findings, we have two main findings. The first one is that lifetime energy cost information has different effectiveness depending on the energy efficiency level, and we cannot ensure that it's going to be always effective. Then another surprising result for us was the impact of the renove, this long run effect called memory effect in this case. It's true that having a renove program once it is over could encourage the purchase of highly efficient appliances. So we believe that a lot of research should be done on rebate programs to ensure that this effect remains on the time. Then regarding the policy recommendations, one of our policy recommendations could be we propose to implement different monetary labels depending on the product category. And this is all. I believe that I've been really fast, as no one is controlling my time. Okay.
You're okay, Mary. It was like 80 minutes.
That's perfect. I have no idea if someone has any questions for me.
I actually have a very basic question regarding your experiment.
Okay.
Yeah, when you calculated the lifetime cost for the appliances in your experiment, do you actually find that the lifetime cost for the A triple plus, or say the best class, is lower compared to the second best class, the lifetime cost?
The thing is that we didn't have in our experiment any A-level appliance.
Yeah.
We didn't have any appliance, any sale of that category.
Okay, yeah.
El Corte Inglés is usually characterized of selling high-level appliances, I mean, with highly efficient ones.
Yes, but yeah, I'm not sure whether in reality the higher efficiency appliances are always the cost-efficient ones. I think sometimes they may cost more.
Yeah, sometimes yes, but in general, for example, in the case of fridges, you could see that in general, A++ products they consume less than ones, for example, A+ ones. At least in our experiment, this is what we have seen.
Okay, cool. Yeah, I was always curious about such monetary treatment, whether they indeed see that the lifetime cost is lower for the efficient ones. Thank you.
Mm-hmm. You're welcome. James, you could ask. The sign of the effects are clear, but just wondering on the magnitude of the change. In some cases, the magnitude is quite small. In the case, for example, of washing machines. But in the case of washing machines, the magnitude is small just because the great majority of sales in the case of washing machines were already at triple plus in El Corte Inglés in this field experiment. We have in the control group, we have 98% of the sales were already a triple plus. But in the case of washing machines and dishwashers, this magnitude was higher and significant, I mean.
Yeah, I know. I'm like, say hello. How are you doing? Eleanor Denny has got a number of findings in relation to other appliances. We've done some analysis on tumble dryers here years ago, but she's done some new work on other appliances, which I think is actually results are quite similar to what you found. So suggest maybe dropping her an email. Might be something useful there in a collaboration.
Mm-hmm. This is what the thing I was explaining to you. In the case of washing machines, you could see that in the control group we have a high level of A++ sales. But in the case of fridges, dishwashers, and tumble dryers, this amount is smaller. This is just the percentage of sales per appliance, energy efficiency level, and group.
Gotcha, okay.
You could see that here we have the same problem as in small retailers field experiment.
Thanks very much.
You're welcome. I'm not sure if someone has more questions about that. No, that's okay. Okay, I think that we've been really fast. but it's been a pleasure to listen to all of you. And thank you very much for participating in this session. That's all.
Thank you.
Thank you very much, all.
Very much.
Thank you. Thanks so much.
Thank you.
Bye.
Bye-bye.
Bye-bye.
I think that it's over, no? You can stop recording.
No. yeah.
It's been really fast. I know.
Yeah, depending on the number of attendees and
yeah, and the questions. I mean, there were no questions. I was the only one making the questions.
I mean, but we still had some attendees, you know, we had some sessions that is just the speakers and
well, no, we have 10.
Yeah, exactly.
10 are not too much. And James was a colleague. I mean, I've been doing my research stay with James, so
so he knows the project.
Yeah. Okay.
Okay, perfect. By the way, interesting presentations. I mean, I was really curious about all the methodology that you did, but
I was really fast, I know, because I explain very fast and I try to be as smooth as possible. Because sometimes I believe that, I mean, long presentations are really tough to continue in, I know.
Okay.
I try to be fast. Okay.
All right, perfect. Thank you very much, Maria, for being the chair for the session. Very good presentation.
You're welcome.
Very good sharing. So enjoy the conference and see you in another opportunity.
Yeah, see you. Bye-bye.
Bye-bye. See you.